Hi guys. All right. So I'm going to do matrices 2. Matrices 2, right? So matrices 2 has got things that we call determinant, and inverse, and inverse. Right. Determinant here is sort of like it's given in this form. If we're doing matrices, this modulus here is it's a determinant, right? And then inverse is a to the power minus 1, something like that, right? Okay, so let's say we have a is equals to 3, 4, 5, and 2, and then the question say find a inverse, right? Now a inverse, we can't find a inverse if we don't have determinant of a. Determinant of a, I said we can just write in this form. Determinant of a, it's something like this, is equals to, if you're finding determinant, you cross multiply these ones here and then put a negative in between. It's 3 times 2, then you say minus 4 times 5, right? 6 minus 20, that's minus 14, right? So if you're going to have to write the inverse now, you say inverse of a is equals to 1 over determinant 1 over minus 14. These ones, they change sides, like 2 comes here, 3 comes here. These ones change signs, they were both positives, so we're just going to say minus 4, 5, and 4. I want you to note something. These ones are changing sides only. It means they rotate. This one 2 comes here, 3 comes here. This ones, they just change signs. That means it was a positive, it became a negative. It was a positive, it became a negative here, right? So since you know that positive and negative, yes, the whole thing becomes minus. That's how you write these things here, right? So this is the inverse. So if you're asked to find the inverse of something, you write something like that, right? All right, let's do another example. We have a matrix which we call a singular matrix. Singular matrix, right? Singular matrix is the same as a matrix has no inverse. It's one and the same thing. If they tell you that a matrix is singular, it's the same if they tell you that this matrix has no inverse, right? Now, a singular matrix has determinant is equals to 0. So for all the singular matrices, determinant is supposed to be 0, right? So let's say they say if x plus 2 is singular, if that matrix is singular, find the value of x, right? So we're saying that if this matrix here is singular, find the value of x. What it means is if you find the determinant of this matrix here, it's supposed to be 0, right? So we cross determinant, we cross multiply, and then we put a negative in between. So we multiply that one there, negative 2x plus 2, then we put a negative here, 2 by 3. This is how you find the determinant. So we know that it's a singular matrix supposed to be equal to 0. We multiply minus 2x minus 4. We multiply the minus 6 is equals to 0, right? Let's simplify here. Minus 2x, that's negative 10 is equals to 0. Minus 2x. Let's bring 10 on the other side then. It becomes 10 over negative 2 over negative 2. X is equals to, remember this is a positive. Positive and a negative is supposed to become a negative. So this is it. So I said if they are telling you that this matrix is singular or has no inverse, it just means that the determinant is 0, right? Okay. Right. We also have got what we call identity matrix. Identity matrix, it's represented by letter I. So if you see anywhere that is an I or a bold I, they're just trying to tell you that it's an identical matrix. All right, it's messed up here. It's sort of like I is equals to 1 0 0 1, something like this, right? That's I. All right, so usually it works with examples like if, let's say, a 3 2 b multiplied by 2 1 3 1 is equals to I, and then they say find the value of A and B is something like this, right? So you just know that you don't have a matrix here, but it's I. That means the matrix that you're supposed to write here, it's an identical matrix. So we say A 2 3 B 2 3 1 1 is equals to 1 0 0 1. Since we know that identical matrix, it's this one. So we say row by column. Since we're multiplying, we say row by column here. So say A times 2 plus 3 times 1. The other one is A times 3. A times 3 plus 3 times 1. This one is going to be, say, 2 by 2 plus B times 1. The other one is going to be 2 by 3 plus B times 1. This goes to identical matrix, something like this. If we multiply there, it's going to be 2A plus 3. It's going to be 3A plus 3. This is going to be 4 plus B. This is going to be 6 plus B is equals to 1 0 0 1, our identity matrix. Now what it means is we're just going to have to know that this one is equal to this one, right? And this one is equal to this one. And then we equate those ones, and then we find our values of A and B. Let me just finish for you. 2A plus 3 is equals to 1. 2A is equals to 1 minus 3. 2A is equals to minus 2 over 2 over 2. A is equals to minus 1. The other one was 6 plus B is equals to 1. 6 plus B is equals to 1. We can leave B here, and then we say 1 minus 6, B is equals to minus 5. That's how you find the values of A and B. Right, so what I'm just trying to tell you is that if they tell you about an identical matrix in I, you just have to know that it's 1 0 0 1. We will use this matrix when we will be doing transformations. So just hang in there. All right. So that's it. Let's talk about the other one. This is the last one, which you call zero matrix. Right. Zero matrix. It's sort of like it's a matrix with all the zeros. Right. I've never seen this one being used, but it always gets used a lot, right? Alright, fine. So that's it for my matrices. Let me just leave you some homework. Alright, let me give you some homework. Okay, if you're able to do these ones, that means you have understood the matrices. I'll see you on the next video, guys. Cheers. All right, be well.